Hi, my name is Neil Joshimpillai, and I'm bringing you this presentation on SQL Profiler. Okay, so first let's start off with what is SQL Profiler. The way I'm going to break down this presentation is that initially I'm going to go through the slides, then I'm going to go through SQL Profiler's GUI, and then I'm going to walk you through the actual command line operations for SQL Profiler. So if you want to skip ahead to see another portion at any point in time, feel free to if you already know the basics. So what is SQL Profiler? Well, SQL Profiler is a tool included in the Microsoft SQL suite that allows for the monitoring of your database's activity. It generates trace files that can be used for analysis and diagnosis of problems in your database. You can either run it from SQL or via the GUI. So if you run it for SQL, the profile will just be running in the background. Okay, so who uses SQL Profiler? There are three main roles that come to my mind of people that use SQL Profiler. The first are database administrators, the second are database developers, and third would be database testers. Database administrators can use it for recording database activity. Database developers can use it for monitoring front end, as in the actual website's calls to the database and the parameters the front end website passes to the database. And higher level database testers can use SQL Profiler for identifying problems, bottlenecks in performance, and deadlocks. This is a snapshot of SQL Profiler's actual GUI, which I'll actually be showing you shortly. And here's some more SQL Profiler uses. You can use a filter in SQL Profiler to search for particular operations that occur in your database. You can use templates to record the filters. I will show you an example of a template later. And you could feed the trace file outputs from Profiler into this other tool that comes with SQL Profiler called a Database Engine Tuning Advisor to get tips on improving your database's performance. Okay, so now let's go and open up SQL Profiler. So in order to access SQL Profiler, what I have right now is SQL Server Management Studios running. I'm pretty sure you could run it directly from here, but I normally go through SQL Server Management Studios. Yep, here's SQL Server Profiler. You can either run it from your start menu, or you could run it through SQL Server Management Studios and click on SQL Server Management Studios, which I'm doing right now, and it'll start up. Then you enter in the connection parameters for the database you're connecting to and that you want to run SQL Profiler on and monitor. So then you click connect. This is the GUI, by the way, if you haven't realized it yet. With SQL Profiler, when you're monitoring the activity, you could choose to save the actual monitoring data or trace to a file by clicking on this in the actual general trace property settings. Then you can specify what you want to call it. Let's call it GA, and save it on D drive. Save. And you could even save the trace file output to a table in a different database if you wanted to. So you can connect. I'm going to save it to timesheets, and I'll call the table GA. And okay, you could limit actual amount of data that is saved in the table by setting the maximum amount of rows. Note that it's in thousands. You could also say when you want this trace to stop, so you can set a specific time and date. I don't want it to stop because I'm going to stop it manually. You could also set a file rollover for the files, so if you wanted the files to have a particular maximum size, you can say you want it to be either 5 megabytes, 1 megabyte, or how many ever megabytes you want. What this will do is, in case you run out of space, you're not going to lose the files because it's not going to be left open-ended. You can also use templates, but for now I'm not going to use a template because I'm going to just show you how to, that'll come up later. Here I'm going to specify the trace name as ga, and I'm going to only record the batch complete events. Each of these events have different meaning. The batch complete event is actually whenever batch has completed running. So you could look up on the MSDN site for what each of these different events mean. You can also choose the columns you want, like text data, application name, NT, user data, login name, reads, writes, which is, and duration of that particular batch took to run, and various other information. Over here, as you can see, you have the option to show all events, so that will give you a list of more events if you want access to them. Some events I've used in the past outside the batch complete are I think in errors I've used the blocked progress report to see whether which processes or stored procs were blocking each other. I've used the I think it was database. No, it wasn't database. I've used performance, no, locks to see deadlocks. You could use the deadlock graph to actually find out which processes are locking up with each other, and stored procs are locking up with each other. It's a little bit more complicated for finding deadlocks, and I'm going to put that into a separate presentation. But for now, that's all you have to know. So by clicking show all events, you'll have options for looking at the trace for other information. Here with the batch complete, I have these columns. If I want, however, those aren't all the columns I have access to. If I wanted additional data for the batch completed operation, I could even record things like the database ID, the database name, whether it's an error or not. Things like the host name, is system, and all these other column information. I could store that in my trace file and table. But for now, I think that's enough. So I'm going to start running my trace file. So when I run this website, which is actually connected to the database I connected to, so I do an activity, since this is a dynamic website that interacts with the T-SQL database. So I'm clicking that. There are no details. However, it's going to make a call to the database, and as you can see here, what's happening is that it's making a call to a stored proc, and it's passing in information. So I get to see what the front end is passing in. This is the actual data it's passing in. This is an action I'm passing into my stored proc. You might not know what that means. However, these are basically the parameters the front end website passes to the back end website. So here I have a visible information. So what I did, how I set up this database, is that I made it so that it would pass in from the front end website a session ID. So that way I'll be able to identify which browser is interacting with which browser's session is interacting with this, or making this particular stored proc call at any particular time. That is useful for not just debugging but development. It makes things a lot easier. So since I only want to record events that have the session ID in it, what I can do is pause it, go to event selection, go to column filters, go to text data, and I could put in %, the session ID, the %. So now I'll only get activity from this user. If I wanted to add another session ID, I could just press enter, and I could enter in another session ID, %. So that by using the enter key, I could look for more than one filter on a particular text data event, and I could even choose to omit particular search criteria in my store proc calls, and I don't just have to search on the text data column. I could put filters on different columns that are in my trace, but for now I'm only going to look at the text data column, and I'm going to run it again. So it's basically applying that filter to this column. I could have made it so that would apply the filter to, let's say, NT username or login name. That would become useful when multiple users were testing the same database. And so, since I'm saving it to a text file, as you can see here, I'm saving it to a trace file, and my trace file is right here, ga. This is an old trace file. So basically, whenever activity happens in my database, I'll be able to see it in the GUI, and it'll also simultaneously save to this trace file. In this manner, if I wanted, I could keep a log of the activity in my database as well as the users and other various informations. I could find out when there were deadlocks if I had chosen that option in the filters, in the event properties, which is over here, event selection. I could have chosen to show all events and added deadlocks into that information and various other information. So let's say I wanted to save the settings I had here. Like, in case I just didn't have batch completed, I could have had deadlock graph as another event I wanted to save. I could have wanted to save only particular column data, and I could have a particular filters applied to my data. If I wanted to save that and import it into another person's computer without having to recreate it, I could go to export, templates, I would say the server type, and then I will specify the template name. Let's call it Nealon1, and the template saves as .tdf, and I would click save, and it will give me the message that the template was saved successfully, and I will go to OK. Then when I go here, I have access to that template, and if I wanted to, I can go to File. When I'm creating a new trace, I could connect. I could choose to, whoops, no, first, before I even do that, I would have to templates, I would have to import the template. So I'd find the template file, which is Nealon1, okay, and then it would import it. So then when I create a new trace file, I would have the option of choosing that template right here. And it would, by having selected that, all my event selection stuff would be the same as what I had previously chosen. So as we go here, it's not right. The filters would be the same. I did something wrong, but now you should understand what I meant. Okay, so another cool thing I could do is I could export the trace definition as a SQL file. So I save as SQL.SQL, and then I will get an actual SQL script that will run my my trace in the background. So if I was to run this, it would basically run Profiler without opening the Profiler. So I could do all that without having to open Profiler GUI. So if you look over here, it saves all the trace filter settings, and it even will, you can even specify where you want the trace file saved. You'd enter the trace files like c/trace.trc, and it'll save it to a file. So now let me show you another useful command. The two main commands you have to know are, after you create your actual trace, are this command, select star from fn underscore trace underscore get info. Basically what this does is give you a list of all the traces that are currently running. And this will basically set the status of a particular trace ID. So let's say I wanted to stop this trace ID, because this trace ID is what's saving to a file, right? So I'm going to say put in the trace ID of 1, and I'm going to set the status to 2. By setting it to 2, what happens is that it pauses my trace. And before I can stop a trace, I have to pause it. So whenever you stop a trace via the GUI, it first pauses it and then stops it. So I run pause. Whoops, I mean 0. Set status to 0 first. Wait, let me see. Select. Set status 0, 0. Status of 2. So as you can see here, I can't affect the first trace file, but I can affect the second one. So I set the status to 0, and after I set it to 0, now I can stop it. So now I only have one trace file running at a time, which is the default trace on my system. In summary, I have shown you in this presentation how to use the SQL GUI so far, and set filters on the SQL GUI, import and export templates, run SQL Profiler from a command line, from SQL Server Management Studios itself. And finally, I'm going to show you how to feed the output of a trace file into the database tuning advisor. Now, let me forewarn you that the database tuning advisor isn't 100% accurate, even though they say SQL profilers or the suggestions it make should be kept as suggestions. You should really use your inborn knowledge before making any changes, because sometimes it can only be useful in one particular situation. So what I'm going to do here is import a file, which is the trace file. So I import ga. So the trace file basically contains the database's activity. You could choose to tune that particular database. You can go to tuning options, and you could say what time range you want it to look at, and you could also specify what you want suggestions for tuning. You could even say whether you want to suggest partitioning strategies. And you could set advanced tuning options. So once that's done, you can click on Start Analysis. And it'll start. and then the tuning advisor will run using the actual trace file as an input. It's taking an incredibly long time, and then it's going to give you suggested recommendations. So here, index recommendations. So it's looking through your code over here. In my case, it might have had a little bit of difficulty because it's not good at tuning XML store procs. Mine is using a more newer concept rather than basic SQL, and it doesn't work well with dynamic SQL either. However, what will happen is that it will generate a report as well as SQL to optimize it. I realized what I did wrong. You shouldn't put filters on your actual the filters I also used weren't very useful. So it'll give you, after this is done, technically what it should do is give you SQL commands to modify the indexes on your particular tables, etc., etc. However, in my case, since I didn't, I limited the actual events that are recorded. It's not going to give me that information. And that is all for this presentation. I hope you found it useful. And that is how you can use SQL Profiler as well as the Database Engine Tuning Advisor to monitor your database and even get suggestions on improving it. Thank you.